Modern engineering has become an increasingly interdisciplinary profession, requiring the input of several engineering fields as well as non-engineers, while considering the impact on the community and the world. To explore this complicated design process, we've decided to study the common problem around installing a wind farm in a rural community. A wind turbine is a device that converts the wind's kinetic energy into electrical energy. Wind farms are used by many countries as part of their strategy to reduce their reliance on fossil fuels. However, some citizens are still concerned that the noise produced by wind turbines may have potential negative effects to human health. Therefore, this project needs the cooperation of many engineers and non-engineering disciplines in order to succeed. Wind turbines contain several entirely different systems that work together to run the machine smoothly. Engineers in a discipline can only legally provide professional design input in their own areas of expertise, necessitating an interconnected design for and implementation of the wind turbines. The three main engineers involved in this process are civil engineers, who design support structures for turbines as well as related infrastructure such as buildings and roads. They must make sure the foundations are adequate to support the turbines under extreme load. Electrical engineers, who create and test the electrical components of turbines involved in creating electricity. These include motors, generators, communication systems, and electricity transmission systems. And finally, mechanical engineers, who design, develop, and test the machines involved in operating turbines and wind farms. They also work on the machinery manufacturing process used to make them. While working on this project, each engineering discipline focuses on their own system, while combining each design together to finish. This is the most efficient way to design a multi-system machine while minimizing costs and time for design. While engineers must work collaboratively to consider technical aspects of design, working with non-engineering disciplines provides insight into other ramifications of the design, such as human health and community impact. In fact, numerous complaints have been made by several people living in the shadow of these turbines. Symptoms include sleep disturbance, headaches, vertigo, and several others. Engineers must consider the impact of their work on human health. However, they cannot perform medical research on these issues, which is why doctors have been asked to intervene. For example, Dr. Nina Pierpoint, a pediatrician, argues in her book, Wind Turbine Syndrome, a report on a natural experiment, that wind farms do in fact have a negative impact on human health, and proposes the installation of wind turbines 2 kilometers away from homes. Others think that it's a nocebo effect, where health complaints can be explained by the influences of negative expectations. In a 2014 paper, 4 doctors argued that the effects on human health from wind turbines are based on negative information. They were able to find similar results in other related projects when people were exposed to the same predispositions. However, this seems to contradict the evidence from Nina Pierpoint, creating a great deal of uncertainty about the effects of this engineering project. With evidence pointing in both directions and people's health at stake, the opinions of a professional are paramount to ensuring that the project does not cause any harm to the community. In the same manner that a doctor would not be able to design a hospital without engineers, engineers must rely on the expertise of other medical professionals in order to create the most informed design decisions. These debates bring us to the role of politicians in this project. In fact, politicians and the government have to make a decision and choose to invest in the execution of this project. They must balance several competing factors for the community's resources and their political platform. The public can be strongly polarized on these issues, such as in the 2014 Ireland protest, which saw 7,000 protesters march against the installation of new pylons and wind turbines. Ultimately, the decision to invest in renewable energy is at the government level. For example, Ken Salazar, the Secretary of the Interior of the United States, took the decision to decrease the number of wind turbines from 170 to 130 to answer the objectors of a wind farm project in Nantucket Sound. The issues facing the world today are some of the most complicated and contentious issues ever faced by mankind. We've demonstrated the need for cooperation and understanding in between 3 engineering fields and 2 other disciplines for a relatively common issue. If engineers are not able to install a wind farm on their own, how would they be able to solve climate change without the help of other fields? To be a successful engineer in the 21st century, being able to communicate with other disciplines and work together to solve issues is not only the right way to practice engineering, it is the only way to practice engineering.